So here we are told we have a ramp that has an angle theta, and there's a ball sitting on this ramp with cables wrapped around it, producing a magnetic moment. And the magnetic moment makes, of course, an angle of theta with a vertical, because theta is the incline of the ramp. So they tell us that there's a magnetic field pointing upwards everywhere in space. So because the magnetic field points upward in space, there's a magnetic torque. And the torque is the cross product of the magnetic moment with the magnetic field, so it's this. So the magnetic moment is just the number of turns of the wire times the current times the area. And now we can just see that this torque is going to be also clockwise because it wants to align the magnetic moment with the magnetic field. So this is a clockwise torque around the center of mass. But gravity produces a counterclockwise torque. So what is the torque that gravity produces? Well, the torque that gravity produces is just the force of gravity acting on the center of mass. Here, let's draw it in a bigger diagram. So here's the force of gravity, and the angle here is theta. So the torque that gravity produces is just equal to mass times gravity times sine theta times the distance r, this distance r. If we're looking at the torque about this point. So gravity produces this. These two torques are equal, the magnetic torque and the gravitational torque, because the ball is in equilibrium. So we just set these two things equal to each other in this way. And if the two torques are equal, we can cancel out the sine of the angle. And now we could easily solve for the current I from this equation. So I turns out to be this thing. And now we plug in the numbers for the mass of the sphere and gravitational constant. The number of turns is 5, the magnetic field 0.35, and the radius. We know all of these numbers. So we find the current. And now we can see that, so this is the current is in amperes, or in amps. So we see that this whole expression for the current does not depend on the angle theta.